we'll be reviewing the concept of non-permissible values. Recall that non-permissible values are values of x or another variable that when placed in the denominator cause the denominator to evaluate to be 0. So if we look at my first rational expression, I see x over x squared minus 9. So what I'd like to do to start solving this is to factor the denominator. So x squared minus 9 is a difference of squares, meaning I'm going to factor that to get x minus 3 and x plus 3. So now, I know that if either one of these expressions, the value is 0, then the whole denominator will be 0. So what I'd like to do is use the zero product property and set each one of these equal to 0. So x minus 3 equals 0, and x plus 3 equals 0. Now solving these for x, I get that if x equals 3, or if x equals a negative 3, then my denominator is going to evaluate to be 0. So I would say that x can't be, or is not equal to, positive or negative 3. So that was using difference of squares. In the second expression here, we see x minus 1 over 3x squared minus 12x. So we have to take each of these rational expressions on a case-by-case basis. And remember, we need to continually evaluate what type of factoring is necessary to simplify the expression. So in this case, I see 3x squared and 12x here. So I see a common factor of x. What I also know is that 3 and 12 are both divisible by 3. So I'd have a common factor here of 3x. So if I want to remove the factor of 3x, I would divide the first term by 3x, and I'd have an x left. I would divide the second one by 3x, and I'd have minus 4. So again, I want to use the zero product property and take each part of this and set it equal to 0. So in this case, I get x equals 0. That's one non-permissible value. And in the other case, I get x equal to 4. So I would move back up to my expression and I would say that x can't be equal to 0 or 4. And these would be the non-permissible values for each of these expressions.